Okay, this is going to be a series of videos, so the one you're watching is only one of a series, and I do encourage you to watch the rest of them. Also, I encourage you to watch the full-length webumentary titled Global Warming, Myth or Reality, A Skeptic's View. It goes through the entire science behind global warming, but with this series, we're going to pick and choose some interesting pieces, and we're going to ask the viewer, does global warming pass the stink test? We're going to take a look at the science, and I want you to ask yourself, does that even make sense? Most importantly, ask yourself, if a big oil company produced a report like that, wouldn't the environmentalists be going ape nuts? Because what we're going to do is we're going to take a hard look at the science, and then once again, just ask yourself, does this pass the stink test? Okay, if anyone's ever taken Basic Economics 101, you know that whenever you do any kind of a study where you're dealing with multiple variables, there's the term that they always use. It's called ceteris paribus, or all else held equal. Typically, when you're running an experiment, you want to hold as many variables at constant as you can. That's why they use these terms, controlled environment. Well, let's take a look here at the chart that they have for carbon dioxide. The left half of it is from ice core data, and that comes from the Arctic. That is sea level. The right half of the chart comes from Mauna Loa. That is a CO2 spewing volcano. So right off the bat, as far as the violation of the ceteris paribus principle, this global warming theory is way off. You could not find more different variables in the sources that they get than the way that they've done this. More importantly, taking it Mauna Loa is done at a huge elevation. It's at 13,700 feet versus sea level. Now you have to start thinking, well, wait a minute, doesn't CO2 vary as you go up in the atmosphere? And sure enough, if you look here at the chart, down at the bottom, especially on the bottom one's a dramatic example, you can see that as altitude increases, CO2 concentration also increases. So by going up so high, they're automatically increasing the concentration of CO2 in the atmosphere if they happen to be taking it during that month. You can see other months it actually decreases. The other problem that you have is data contamination. Now remember, when you're up in the Arctic, you're dealing with no biomass. There's basically just frozen tundra there. There's no trees, nothing's breathing, nothing's decaying. There's no smokestacks. There's no anything. Well, let's compare that data sample source to Mauna Loa, and let's see, is there a possibility that there might be some data contamination? Because the last thing you're going to do is contaminate data. Well, let's take a look at what's going on out in Hawaii. Okay, when you go out to Hawaii, you've got hippies out there smoking the Maui Wowie. You've got jets polluting the air around there. There's airports on all the islands. You got tour buses spewing smoke. You got cars spewing smoke. You got tour buses spewing smoke. You got tourists spewing CO2. So if you want to find an area where you're going to go do an air grab sample and you want to have contaminated data sources, Hawaii's probably your top pick. If you want to have a pure source, you'd probably want to go up to the Arctic. Well, once again, the rule of ceteris paribus, all held equal, is tremendously